Hey, so we are looking at graphing polar curves. So you should, by this point, know how to plot points, and you should also know your unit circle. Those are two things that are necessary in plotting polar curves by hand. There is a way that you can plot polar curves using a graphing calculator, but then you're not really plotting it, you're just using a device to do it for you. And we're doing this by hand, and that's the whole purpose, is doing it by hand to get the exact value and the process behind it. So we have our table, and our table here we see it goes from 0 to 2 pi, and we have every single angle measure along the unit circle: pi over 6, pi over 4, pi over 3, and their multiples. So this is going to give us a good representation, a good curve, because we have enough points here for this. So let's plot 2 minus 6 cosine of 2 theta. So let's just work this out. So if I want to know what R is when theta is 0, so we have 2 minus 6 cosine 2 times 0 is 0. So we know cosine of 0 is 1, so 2 minus 6 is negative 4. All right, so that's where knowing your unit circle comes into play. So looking at the next, so we have 2 minus 6 cosine. If I multiply pi over 6 by 2, it becomes pi over 3. So pi over 3 is 1/2. So half of 6 is 3. So 2 minus 3 is negative 1. And then, if we have pi over 4, that would be 2 minus 6 cosine. 2 times pi over 4 is pi over 2. Cosine of any 2 is 0, so we get just 2 minus 0, or just 2. Okay, then repeating this, 2 minus 6 cosine, if I multiply this by 2, nothing cancels, so it's left 2 pi over 3, which is negative 1/2. So negative 1/2 of negative 6, that's positive 3, and so 2 plus 3 is 5. And then say pi over 2, we get here 2 minus 6 cosine, if I multiply pi over 2 by 2, then that's just pi. Cosine of pi is negative 1, so negative 6 times negative 1 is positive 6, so 2 and positive 6 is positive 8. So I'm going to go through the rest of this, guys. I encourage you to do this as well, whether you have a copy of this table, whether you're just making your table yourself. Go ahead and do this along with me. All right, so we get our table here. This probably take the most time out of this whole entire problem, just filling out the table, because yes, having this many values will give us a good picture. If my increment's less, then our graph is not going to look as clean, as precise. So I want to note here, the right side of my column, once I pass pi, now if this was sine, it may be different, but with cosine, once I pass pi, my numbers start reversing. They just repeat in the other direction. So 7 pi over 6, so this 7 pi over 3 here, I related it to this 5 pi over 3. And then this 5 pi over 2, I related to 3 pi over 2. And I just kept, when I noticed the pattern, it saved me a lot of time in completing the table here. So now we're going to plot this. So using this table, we're going to plot. So assuming you have the table already written down. Let's talk about us graphing this. So remembering how to graph polar curves. Think of the angle measure and then apply the radius. So I have an angle measure of 0, but my radius is -4, so I go in the opposite direction 4 units. So 1, 2, 3, 4. Okay, then at pi over 6, I have -1, so -1 takes me to the other side on the first circle. Okay, and then to pi over 4, I have +2. So at pi over 4, I have +2. So one mistake that we can make here, first of all, is just not plotting our points on the correct distance from the center, the correct circle. Just be very, very cautious as we go through. Then at pi over 3, we have 5. So 1, 2, 3, 4, 5. Okay. At pi over 2, we have 8. 5, 6, 7, 8. And then we have 5 again at 2 pi over 3. Stuff's going to start repeating. And then at 3 pi over 4, we have 2. Okay. And then I'm going to connect what we have so far. Making sure we connect our points in progression as we go along. And then at 5 pi over 6, we have -1, so I go to the other side. There we go. And then at pi, we're at -4. So over here at pi, it's -4, so I go through it to the other side. Okay. And then at 7 pi over 6, we are at -1, so -1 takes us to the other side. Right here. And then let's see where we're at now. We're at 5 pi over 4, we're at 2. So 5 pi over 4, we're at +2. So we're not going through it because it's +2. So we are right here. So let's go and connect what we have. So like that. Okay. And then at 4 pi over 3, we're at +5. So 1, 2, 3, 4, 5. Okay. And then at 3 pi over 2, we're at 8. Okay. At 5 pi over 3, we're at 5, so we're in symmetry. So 1, 2, 3, 4, 5. Okay, so we can go and connect what we have here. Okay. And then at 7 pi over 4, we have 2. 7 pi over 4, we have 2. Okay. And then at 11 pi over 6, we have -1, so it takes us to the other side at -1. Okay. And then we have, let's see, -4. At 2 pi, we're at -4, so we're over here. So we get our curve. So this is like an example of a polar curve that really, in rectangular, you probably could not get. So it's just a matter of knowing your unit circle, guys, knowing how to plot them, going with the angle measure and then the radius, and connecting them in progression. All right, we don't want to plot all of our points and then go back and connect, because we might forget how the points follow through. So connect them as you go. Really just repeat this pattern with any sort of polar equation. And if you have to approximate, let's say we had a table where we have to approximate, like maybe you get 5 square root of 2 over 2. Well, you would simply get the approximation for that, and then on your circles, you would go out that value. So you might be between 2 circles there. Okay, but approximations are fine. Just the decimal value, approximate where that would be as far as the distance from the center. Your angle measures, you should always be following on those labeled angle measures. And there's nothing more to it, guys. You're going to continue this and practice it and look at other curves and other types of polar curves. So good luck with that, and I'll see you in the next lesson.